This is the AAMAS demo video presentation for RMASBench, a benchmarking system for multi-agent coordination in urban search and rescue. RMASBench is a benchmarking system that provides numerous performance metrics in order to evaluate both the solution quality and the computational cost of the user-implemented DCOP algorithm. We decided to develop RMASBench for two main reasons: the difficulty to implement new algorithms and the limited number of agents involved in the simulation of other benchmarking systems due to the elevated computational cost. To address the first problem, in RMASBench the low-level components have already been implemented, so that it is easy for the developer to implement and test his own DCOP algorithm. The developer only needs to derive a class from the decentralized assignment interface, which provides the basic functionalities of a DCOP algorithm such as message exchange and assignment computation. Two algorithms have already been implemented and can be used as basis for comparison: MaxSum and DSA. During the execution, n instances of the algorithm are launched, each representing a single agent. To compute their assignment, the agents possibly need to exchange an elevated number of messages. This is made possible by a layer of communication called ComDispatcher, which overcomes the limitation of the standard RoboCup rescue simulation platform. The kernel becomes involved in the communication only when all the agents have chosen their assignment. To help with the execution of tests, RMASBench provides a simple GUI through which the user can set the desired parameters. For some of the parameters, such as the starting time, it is possible to specify more than one value at once. The system will execute all the possible tests with all the possible combinations of parameter values. Here is a brief example of how the benchmarking system works. We have created a scenario in which 12 firefighters have to extinguish fires originating from 3 ignition points. They coordinate using the MaxSum algorithm. At each time step, every firefighter is assigned his target and either moves towards it or tries to extinguish the corresponding fire. At the end of the simulation, all the metrics of the experiment can be converted in graphic form for an easy evaluation of the performance of the algorithm. To address the second problem, which is the limitation in the number of agents involved in the simulations due to the computational cost, we decided to implement a crowd simulator using the CUDA technology to take advantage of a GPU ability to perform parallel computation. In this way, it is possible to perform simulations with an elevated number of concurrent agents, as shown in the clip. Through experimentation, it is possible to demonstrate that the crowd simulator creates realistic behaviors for large-scale simulations. In the graphic is shown how an evacuation simulation performs in cities like Paris, P, and Berlin, B. In particular, it shows how the evacuation simulation behaves as the block roads ratio increases from 0 to 0.2.